And here's the start. That should keep me from having to do this as much. Institutor, if you guys want me to present the slides for you, pop them into the slides channel, I guess, on RCOS is probably the best way.
Yeah, can I share my screen?
You can share your screen.
Yeah, okay.
It will take me a few seconds to get set up, but you can certainly do that. Let me just you go ahead and you go ahead and share it. And what I'm going to do is I'm going to figure out how to get the WebEx in instead of All right. See, now we've got an infinity of presentations, which is good because that's what we expected. And then I can come over here and unpin myself. And there, we have Institutor coming up. All right, I am going to, can you say something? Let me just make sure I'm getting you on the recording.
Okay, can you see my screen correctly?
Yeah, we can see your screen, I think, and it looks like that's what I'm taping, and we can hear you. So I'm going to pop into the audience, and you should feel free to hold forth.
Oh, okay. So then I'll start my presentation. So, okay, hi, welcome to the presentation of Instant Tutor. So today's presentation will be led by myself, Jiang Xuxing, and because I'm the only one who registered in RCOS during this summer semester, and I'm currently studying remotely, so I'm very sorry I could not attend in person. So then let's start. So there are three main parts I would like to introduce today. So firstly, let's take a brief introduction about the Instant Tutor. So the platform Instant Tutor is motivated by the high demand for one-on-one tutoring during the pandemic period. And the basic idea for this platform is match up student and tutor quickly such that they could start instruction as soon as possible. And this is the workflow for the Instant Tutor. So you can see we are currently in the allocation part, which is match up student and tutor. So, and then for the organization during this semester, for the organization during this semester, we are working on two teams, one for implementation, one for research. And I will further introduce the team member and the achievement for these two teams in later slides. And for the communication, so we are using WebEx, Discord, and Slack. We will hold online meeting every week to make status update, and in Discord and Slack, we have voice channel and text channel such that each team member could share an idea and text blocks. And so next, let's introduce these two teams. The progress of these two teams. The implementation team, there are 4 members inside the team, me, Taylor, Samuel, and Kristen. And the right-hand side graph shows the detailed commission we did in this summer semester. So what we did in this semester, first one is the user search part. So in briefly, a user could search others by name and role and view the detailed profile of others. The second and the main goal, main achievement for this summer is user's request. So in briefly, a user could pose a request and dispatch this request to several matched tutors. And then the tutor could give response to this request, either accept or deny. And then the student could make the final decision based on this accepted tutor and finish this stage, start the new stage named instruction. So the third achievement is a lot of side features that are still in progress, such like calendar, chat between users. Yeah, this is the main achievement for the implementation team. So next is the research team. So there are 3 team members inside this team: Curdy, Ankita, and Kristen. And as I said before, we need a ranked list for students to choose when he posts a new request. So this is the main goal for the research team. They will build a machine learning algorithm to recommend a ranked list of tutors, where the ranked position is based on the possibility of the tutor to accept accept the request and get good feedback from the student during the instruction. And the main achievement for this team, so make a lot of research on several paper and P2P recommendation system. Use data sets to train some machine learning algorithms and analyze and extract data, such like capability, availability, and proximity, and communicate with implementation teams about the details of this data. And also, they build a matrix for evaluation. So I think it will be more directly to show you the demo. So I have already recorded a video for that. So please
okay guys, welcome to the demo. So as you can see, I currently logged in as a student named Jason. So what I want to do first is show you how the search bar works. So if I want to say search either student or tutor, so let's click either. So there are a lot of, let's say test. Submit. Oops, a lot of tests. A lot of user named with test shows up. So let's say test one maybe. And yeah, we can see a lot of information about this user, about his biology, about the skill set, the expertise. Yeah, looks good. So let's go back. Now, what I want to do next is to pose a request because I want someone to help me with the presentation actually. So let's say if we can find someone. So what do you need to help with? Let's say RCOS presentation. Subject, computer science. Which level? Undergraduate maybe. Topic. Help me on my presentation. When do you need help? As soon as possible, please. And when are we available? Sunday evening, night, Monday morning, evening, night, Tuesday is a presentation. Oops. How many sessions? 3 maybe. And click submit. So check your tutors. A lot of tutors shows up. So we may also click view profile here. It will show the same page here. So maybe him is okay. Send request. We may send more. Send to all of them. Yeah, but I don't know when will give us response, so I may not wait here. Actually, I already posted a request several hours ago, so let's see what is going on. So check tutors. Oops, looks like someone already accepts my request and others are still checking. So we may click this finalize tutor to finalize the decision, and we may start the instruction with him. So that's all we can do for a student printing. So let's say what a tutor do. Let's say we switch the role to both a student and a tutor. So let's say welcome tutor and student G7. We got one new request. Whoa. And also before we check new request, we could also manage our expertise. As you can see, I currently have expertise on math. So we may add more, such like computer science, courses, articles, something like, yeah. And so let's go check the received request. Oops, yeah, someone wants us to help with fundamental analysis. But I really don't have many time on it. Actually, I still have a presentation for articles, so I may deny it. Yeah, let's deny it. You want to deny this request? Are you sure? Yeah, deny it. Your response to this request is denied. Okay, finish. So that's all what we can do in this institutor. So that's all. Okay. That's all. Thank you very much.
Okay, this is the demo, and the next thing I would like to show is the future plan about Instant Tutor. So as you may know, the project Instant Tutor was started at the beginning of this year, so it only takes 2 semesters, and we still have a lot of work to do. So if you check the workflow graph, you may say we're currently in allocation part, and the next thing we will start doing next semester will be the interaction part, which is the instruction between tutor and the student. So yeah, this is one future plan. Prepare and start the next stage. And there are more things we need to do, such like deployment and UI refinement. We may hold several meetings on the deployment in the next several weeks. And yes, if the process goes well and we did not face a lot of technical blocks, you may see instant tutor shows up in RPI several semesters later. Yeah, that's all what I want to say. Any questions?
All right, do we have any questions? So what happens, this isn't really an open source question, but it is a question about your project. What happens when you make a bunch of tutor requests and then you accept one? Do the rest of them still remain active, or do you need to go in and, are they automatically canceled?
Do you mean that's for a student or for a tutor?
For a student, you sent out a number of requests.
We will have a checking. If I show that we are currently working on a calendar, yeah, we will set up something like calendar or something to make sure the student posts a request which won't make conflict on his schedules. Yeah, that's what we will do in next or in this stage later.
Okay. And you were talking about possibly being deployed soon?
Yeah, we will hold a meeting for such deployment in several weeks, maybe.
Okay. Are you talking to ALAC, or is this just like a CS department thing?
I'm not really. Yeah.
Can I jump in? Hi, Uzmayer.
Hi, Yusma.
Yeah, so about the deployment, I had this chat with, I don't know if you're aware, Julia works at Troy Consultants, and she got me in touch with them, and they are interested in helping us out doing an AWS deployment. And so we're setting up a meeting with them, and let's see how they can help us get the basic model at least up and running.
Nice.
Yeah. So let's see, I'll keep you in loop, because most likely we'll have a meeting like this Friday or sometime early next week. Because I feel that we do have a basic working model. I know that there are a lot of modifications that are still needed. And yeah, the next process is that get the student and tutor in touch with one another. So one of the students is working on having a chat app or something. So those things we can continue, right? But we do have something to be deployed, at least.
Nice. It's always good to get something out there so that people are
Yes.
actually evaluating it.
Yeah. And so, of course, we need a plan for testing. That's another thing that we're working on. How do we, what all do we need to test once it's deployed, and other things.
Yep.
Yeah.
All right. I think unless there are any more questions, let's thank them again.
Oh, thank you.
And I am going to try to bring up the next person. Can you stop sharing your screen?
Yeah, thank you.
Thank you very much. And I will figure out how to share mine again. I love the infinity wave. Come on. And there we go. All right, we have open circuits. Let me grab my computer, because I think I'm going to have to be your time cue, or your clicker there. All right, whenever you are ready, open circuits, feel free to get started. Do we have open circuits here?
Professor Turner, it looks like open circuits needs a couple minutes before they can present. Maybe we should jump or switch to the next one with this one.
Yep, no issues.
Sounds good.
Let's see, after open circuits is Tutorbase. That's good. We'll get our two tutor ones going. one after the other. Tutorbase, you're on Discord as well, I think, ish. Virtual electronic music, Ilaria. Comments from the peanut gallery there. All right, I'll try to give you a signal at about 8 minutes.
Okay.
You'll still have a couple minutes to go, just so you know to wrap up. All right, Tutorbase. Although it's still loading.
There we go.
As soon as I threaten by getting up, everything works.
So this is Tutorbase, in-demand tutors on demand. So what is Tutorbase? Well, basically, it's pretty much the same thing as Instant Tutor. We're trying to connect RPI tutors to RPI students and allow people to better their studies. So what is this feature? So you can connect with tutors, clients can search by class and subject. There's a very simple scheduling process with a nice calendar UI and email booking notifications and reminders. And the development stack we used is the MERN stack. So the team currently is my two project managers, Jason Nguyen and Jeremy Weiss, and the developers are myself, Justin Choi, and a non-RPI student, Brandon Liu. So project organization, so for this semester, I divided into four sections. So I have really no experience with coding at all, and this is my first time on a large-scale project. So for the first couple weeks, I spent my time learning about JavaScript and GitHub. JavaScript because that is the language we use to code the website in. So during this time, I used Code Academy to learn JavaScript. I looked at GitHub tutorials and attended the GitHub workshop too. The next few weeks, I learned about Tutorbase, understanding the code, how to navigate the repository. The long period was all my contributions, creating code based on my research, and then for the last week is just fixing the small errors and bugs in the contributions. So implementation, this is what I did over the summer. So for the login and registration, we wanted to have a developer mode to bypass CAS to make it easier for developers to check the website and fix any errors or bugs. So I used environmental variables to create a bypass so that you don't have to go through CAS. And I also created a new developer help guide that is not yet on GitHub, but I will post it to there soon. So the demo, so this is just like an example of what I did. So when you press login, normally you would be redirected to CAS to log in, but instead, if you have a developer code, you don't have to enter CAS and you can just go directly to the website. And this is just the new developer help guide. It's just like the workshop that I attended, and also the like a couple links that I used to help learn about everything. So what's next? For fall 21, we want to work towards deployment. We want to implement Tutorbase in a production environment, and hopefully by fall or spring, we'll be able to implement this. I know Jason has been talking to ALAC about implementing it with them. We'll see where that takes us. We also want to get new contributors and guidelines and documentation. More contributors are always good. And more good first issues labeled on GitHub. So that means like any issues that are easy for newcomers to tackle. I had a bunch of new issues that I tackled myself. And we also want to have user feedback. We're going to test a lot, confirm that the design, usability, and functionality are all in working order. So for long-term goals, again, like I said, Jason is talking to ALAC, and they are hoping that RPI will take it into consideration and use this for future tutoring. And we also want to create a mobile app and a payment handling system so that people don't have to worry about payment issues and can focus on their studies. And if you want to become a beta tester, scan the QR code and you can fill out this a Google form, and we will notify you as soon as we enter beta testing. Any questions?
All right, do we have any questions for Tutorbase? All right, so I'm not seeing any online or in person. You guys are cruel, and I have to ask questions. So one of the things that I kind of like about open source is this whole Darwinism thing. You know, if you look at, we get nice competition when there's multiple groups working on the same problem, and multiple groups working on the same problem generally means that there's really a need. So, you know, have you guys interacted at all with Institutor, and have you looked at kind of what they're doing? Do you have any idea what the differentiators are, or the difference in the paths that you've taken?
I don't know any of the specifics, but I know that both my project managers have talked to Instant Tutor about the differences and why they decided to create a new one instead of joining on Tutorbase. I don't know this, like I said, I don't know the specifics, but if you ask them, they should know.
No, just that it's you know, there's no right or wrong answer.
No,
You know, it's just a matter of. So, you're the only one working on it this summer.
Yeah, for the
But
summer.
it's been worked on for a couple of semesters.
Yeah, I think it started last summer, so.
And so is the goal to have this continue on and try to bring people in? That's why you have a little bit of concentration for future work on.
Yeah.
Okay.
Yeah, we're gonna definitely work on this for next semester, and hopefully by then we should be in the deployment phase, and we shouldn't need to get too many more new contributors. But for now, we're gonna look for more people to help, and hopefully we can get this started.
And again, I like the idea of becoming a beta tester, because getting stuff, it's the biggest engineering risk is not having anybody using it.
Yeah.
It's the one that we are all uncomfortable letting other people into our stuff. All right, thank you again. I think what we'll do is let's keep open circuits on hold for just a few more minutes, and we'll go off with one more just in case they're not ready yet. So the next one would be Elephant ID. Let me see if I get them set up. Do we have the Elephant ID people? Elephant ID, are you available to go next? And then open circuits, when you are ready to go, could you just drop it in the chat so we know and can begin bringing you in as well?
Wes, on Elephant Book, we have an external visitor who I think was going to join us. Neha, did Sarah update you? So she had 2:15 as the time.
Okay, well we'll move on to one more. I'm sorry.
I'm not sure she's joining us, but let's give her a chance.
Yeah, no, we'd love to. This is not a set in stone.
I can do open circuits right now.
Okay, then we will go to open circuits.
Okay. I should share my screen, right?
If you can share your screen, that would be great. I will move on to
Okay, cool. Oh, all right. Can you see my screen? Is it visible?
Yes, I am trying to get rid of my sharing on the side, though.
Okay.
And unfortunately, it's underneath something else. So I can't get to the pin. There we go. All right. So we will go with open circuits. And then just to lay the framework, just to make sure that Sarah has enough time. Virtual electronic music, will you guys be ready to go We'll go open circuits, virtual electronic music, and then if Elephant ID, and then we'll see where we are with Elephant ID, Elephant Book. All right?
Cool. All right. Yeah, so sorry that I was late. School meetings, they like to keep it the last minute. Hi. My name is Leon Montialegre, and I'm the founder and project manager of OpenCircuits. So a little background to start, if you don't know, OpenCircuits is an online digital circuit designer that is designed to be fast, easy to use, and also allows for complex and detailed design and simulation. Some notable features of the ability to create reusable, integrated circuit components, save and load circuits locally or to the cloud, export circuits as images, and many other quality of life enhancements. Some background, I began this project 4 years ago as an independent study with a professor at another school who actually uses it for his classes. We are also bringing finally OpenCircuits to Comport in the fall with Professor Kuzmin, which is super duper exciting. I founded this project because there didn't really exist any well-made, free, and cross-platform products out there for designing digital electronics. And I brought OpenCircuits to RCOS around 3 years ago, and there's been so much progress since then, it's been awesome. So for our tech stack, it is mostly TypeScript, and the recently added React. We use Sass for styling, Redux for state management, and Golang for our backend, and we host the project using Google Cloud Platform. In terms of project structure, we use GitHub, and we have the BSD3 license. We use GitHub Actions for automated testing and PR checking, and Codacity for code file enforcement. We used to use GitHub Wiki for guides and documentation, but we finally just published a documentation site, which we'll talk about later. And yeah, so I will now get on to the specifics of what happened this semester. So I'll start with myself first. So the biggest thing I worked on this semester was finally getting the documentation site live. And so you can see a screenshot of that in the bottom left down here. And within that, we have design docs that can be written as Markdown, so we can finally have those count as actual open source contributions, and auto-generated JavaScript docs from the actual code, so you don't actually have to write documentation. You don't have to write a documentation file for each piece of code, it just automatically gets generated from the code and the comments within that code. Another big thing I did was I labeled all of our issues better. So we have like a difficulty, priority, and scope tags along with different areas and types, just organization stuff this semester. Another thing that I'm sure Kevin is going to talk about a little bit more later is I began a refactor of our model layer because of what he's working on, which again, we'll talk about later. Here's some more screenshots of the documentation site, and I'll probably do a little demo in a bit. So here on the left is a design doc, a design doc template, and we have this cool little like milestone generated thing. And here on the right is the automatically generated JavaScript doc. And yeah, so Kevin, can you take over?
Yeah, can you hear me all right?
Yeah, I can hear you.
Awesome. So my goal for this semester, which I started kind of halfway through, was to add collaborative editing to OpenCircuits. Because right now, one person can edit it at a time, and only the owner of the circuit can actually view or edit it. So this involved a couple of things. The first is an API, like a simple API for sharing and setting up permissions, and the bulk of the work, which is the design and implementation of a algorithm that's based on operational transformation. Quick idea of what this algorithm framework is you view each operation as like a function application on a state, and then since these applications are happening concurrently across multiple clients, to avoid starving any of the clients from being able to submit their changes, you can transform these changes so that they can be applied in the order that the client that submitted it intended for it to be applied in. Now, in general, this problem is probably one of the easier distributed systems problems. And this kind of diagram of data flow shows the high-level architecture. Most of the core stuff is complete. It's just the odds and ends of actually hooking together all of the subcomponents. That still is yet to be done, and then adding a front end to the permissions API.
Awesome, cool. Next up is Sam.
So I'm Sam. This semester I work mainly on Wait, can you guys hear me?
Yeah, you can hear
Okay.
me.
So like this semester I mainly worked on like UI fixes because I felt like most of the time, if you try to use something and like the UI is just unintuitive or really like bland, it would ruin the experiences. So I just made most of my changes to like as really small things to like help fix what's wrong. Like for example, one of them I made like a static, like one of the options menu for the item navs like static, so you can see it always instead of having to scroll back and to use those specific buttons.
Awesome, cool. Next up is Jen.
Hi, can you hear me?
Yeah, can you hear me?
All right, yeah. So this semester, this is my first time working on OpenCircuit, so I spent a good chunk of time just like trying to figure out and understand the code. But after that, I did a few bug fixes with autosaving, port renaming, and fixing the IC trait view not showing up properly. And then I added in copying and pasting selected components with keyboard shortcuts and dragging components like to have them pull up in the front layer. And then right now I'm working on an issue where signal propagation is inconsistent when you hook an IC in certain cases or when you duplicate part of a circuit.
Yeah, cool. Next is Jeff.
Can everyone hear me okay?
Yep, you can hear me.
Alright, so this is also my first semester working on RCOS and thus open circuits. What I implemented was a few quality of life fixes and UI fixes. For example, the auto save button is currently fixed, whereas before it didn't show up. And I'm currently working on a feature where if you can invert a port.
Yeah, cool. And finally, Longy.
Hello, can you guys hear me?
Yeah, we can hear you.
Okay. So this semester I was working on a user guide for the beginner. So I know like for college students, like it's pretty easy to use it, but like if we could I created this user guide, like the purpose of doing this is we could potentially let more like elementary students or like middle school students try to learn like open circuits or electronics. So I try to make the user guide more user friendly and simple so that like everyone could read it. And in the future I will plan to finish more issues on GitHub or try to like create more tutorials or resources for this project. Yeah, that's it.
Awesome, yeah, thank you. Cool, and now we are live at opencircuits.io as always, and if you add a nightly dot in front, you'll get the most up-to-date version. And then I'm gonna, well, about the plan for the future, and then I'll show a little demo of the documentation later. The plan for the future is we want to do a lot more backend stuff, but that's currently what Kevin's working on. So the most exciting thing is getting collaborative editing working, which is, again, going to be super exciting and super cool once that gets working. I do have a milestone on GitHub currently for a production release. So there's a general easy plan of having another release in the winter, so after this fall semester. So we'll see how that goes. But yeah, lots of exciting things going on. So I'm excited about the future. Lots of documentation stuff, working on DevOps things, making the developers' life better and easier for new people to join. And yeah, let me Right. You guys will see, yeah, see. So this is the documentation site. This is an introduction. We moved all of our wiki stuff in. So for like how to contribute and submit an installation. And so we use is a library called Tutor, and it has some really cool features. One of the coolest things is that not only can you just write all of these pages in Markdown, it's a special kind of Markdown that lets you embed React code into it as well, so you can have React components. And along with that, they have a bunch of built-in components like this tabulated view that also stores which options to use in cookies. So like, for instance, in the installation, you know, I'm using a Mac, so I would use Mac OS, and if I went to another page, that also, I don't think there's another page currently, but if there was another page that used, that requested which operating system you're using, it would remember that I was using Mac, and it would say that. So pretty cool stuff. Has the ability to switch between night and light mode. And then the auto-generated docs are still a little bit janky, but they do work. That's the wrong thing. And yeah, design all that stuff. Yeah, that is that's all for open source this semester. Anyone have any questions? Yeah.
Any questions local? Oh, there we go. Go ahead. Yes. Yeah. Well, and first off, this is really, really beautiful. So, bravo, you know. And perhaps it's kind of obvious in the premise of what you're doing. But I'm curious now that once you've designed the circuit, if there's any affordance to output the circuit as something you could actually get physically fabricated on PCB.
So did you?
Repeat the question? It's really hard to hear.
Yeah, I moved up to the front.
Oh, if you want to translate it.
So basically, I think, and please correct me if I'm wrong, I think the question was, now that you have this ability to design circuits with discrete components, is there any way to kind of export this to something where you can generate a PCB from it, or export for production of an actual circuit?
Currently, no. But that would be a very cool feature to have in the future. It would be super, super cool. So another plan we do have, which is going to be part of my master's project the next year, is working on the analog side of open circuits. So we did originally have an analog version with electrical engineering components, with like transistors and all that kind of stuff. It never perfectly worked very well, but it is a plan. There's a lot of stuff behind them, so they're eventually I am going to eventually revive that.
So
maybe that, yeah.
I was going to say, does Virtual Electronic Music want us? I think they have to get something to get set up. So why don't we have them come up and get set up? And I'm going to ask you, while we kind of kick you off the stage, I'm going to ask you a question that you can respond to while they're getting set up. And my question is, you guys have a lot of stuff going on. I know you've had the analog stuff going on before, and other things. And my question is, how do you guys make the decision on which features get worked on? What's your approach to deciding what bugs get fixed and what features get worked on, and how you kind of plan your development going forward? Because you have a very detailed plan. You've worked on a lot of different stuff, and it all seems to be relatively cohesive. So
yeah. So generally, whenever there's like a new member, I generally let them work on whatever they want. And for the most part, that's what I stick to. If someone is indecisive or I know has the ability to do something really complex, then I try and work with them to implement some of the more complex features. And then in the background, I'm always kind of working on the bigger plan, feature, infrastructure changes, and then kind of maybe guiding people a little bit towards that. And then with the help of like Kevin, who's a superstar. He's the back end guy, so he's doing this whole collaborative editing thing. Yeah, I guess it's kind of a hard thing to describe. We take advantage of the GitHub milestones and stuff like that. So I do have a milestone right now for the next launch, and I put a bunch of issues in there. And I think in the fall, I'm going to very much have people work only on issues that are in there, so that we can prepare for the next production. build. So yeah, I think it's just organization, knowing that generally the bugs are the ones that need to be gotten rid of, the release to production build, and then along with some cool new features. But yeah.
So kind of a benevolent dictator with flexibility.
Yeah, basically. Yeah.
Nothing wrong with that. Okay. I'm getting the slides up for virtual electronic music. We'll see if I can do that correctly. And then we'll have them present next, and then hopefully we'll be ready for Elephant ID. Otherwise, we can wait on that as well. We have plenty of people to look at. Rachel.
Wes, Sarah's not going to be able to join us.
Okay.
Yeah.
So are you?
Pinged her.
Go ahead. I'm sorry.
No, just Neha pinged her and she's not able to join us.
Okay.
So we should go after this.
That would be awesome. Although it would be nice.
Meeting to jump into.
Yeah, it would be nice to have externals, but we will record it for her. All right, I think you guys are good, right? Right, I will step out of the way.
No. Wait, we'll let us skip slides. There we go. Cool. Hey, y'all. We're virtual electronic music. Did we decide we're going to do introductions?
Yeah.
Yeah. Oh, sure.
That'll record it for posterity.
Perfect. We got to have this for posterity. Cool. Hi, I'm Matthew Gant. I've been mentoring.
I'm Rachel.
I'm Drew. And I'm Michael.
Cool. Yeah, thanks for coming out, y'all. So I guess that sort of begs the question, what is virtual electronic music? And that could mean a lot of things. That could be some sort of 3D instrument or some sort of, cube, and you bop the thing, you get the sound. It could also be a Zoom concert, some sort of remote sort of concept. But the way we've been approaching this is rather than sort of prescribing one use case or building one tool that allows you to do every sort of feature, the way we've been kind of approaching this is finding ways to build an elegant and artist or user-friendly bridge between a lot of different technologies. So we've been working with the open source web VR platform A-Frame, which lets you build environments, content, immersive media that you can either experience on your web browser or through any sort of VR headset. And what we've been doing is building a bidirectional bridge using the OSC protocol, which is a way of passing information between various applications, between remote servers, between any sort of kind of context. And we've been building out a tool set, which we're excited to tell you a bit more about soon.
Yeah, so just to give a brief overview of our tech stack. So for the front end, we're using HTML, CSS, and vanilla JavaScript. And for A-Frame, this is also what we use to build out the scenes or the different web VR environments that users can see. And then A-Frame, just a little bit about that. It's built on the 3JS library, and we have created a set of custom JavaScript components that allow you to have more affordances and features in A-Frame. And then for our backend, we're using Node, and we're also using the OSC and WS libraries for server sockets.
Yeah, so kind of moving on to our, wait, are you
Yeah.
Oh yeah, sorry about that.
For the project, we mainly just used GitHub and Discord. GitHub for code organizations, using various of the features like pull requests, branches. We had a few different repositories. But the main repository was the A-Frame audio components, but we have various branches of those. We used forks, pull requests, code reviews. For the communication, we just kind of used Discord. We had our own Discord server. It had really everything we needed. It had a voice channel, which we were able to like show video similarly to WebEx, and we could also screen share on there, and we had bi-weekly check-ins and meetings.
Yeah, so so far we're a new project, right? So we had to start and do everything that we've done so far just this semester. So we started with researching all of this cool technology that you've heard about, and then we actually got into building it a little bit. We got into making the connections between your software on your computer that sends OSC messages and the actual browser where your whoever you're making this art or music for can receive them. And then we also documented use cases, and that was a huge big thing that we were developing alongside the actual messages to make sure that they would keep up with what we wanted to use them for. And so what I personally worked on was that actual routing of your OSC messages from your computer all the way over to your browser, even if they're on separate computers. And so far that only works locally, but we are working on getting it a little bit more than locally. And all of this really allows for a compositional approach to designing. You can have your own software that you know how to use as an artist or a musician and send this data over without changing what you use, without really learning much new. There's just really simple protocol to follow.
And then as for me, I worked a lot with WebVR and A-Frame. So if you didn't have the music software or you want to just control everything within a scene, you could be able to do that. So I used the NPM A-Frame UI widgets, which is a open source package for getting the 3D assets for the different UI elements, and also wrote different components for being able to send data from the A-Frame scene as OSC messages to the software and also back and vice versa. So this has a lot of potential use cases. So on the right-hand side, this is just like screenshots of one of our example environments for using these components. But you could use this as the front end for virtual instruments and also use it to create interactive art pieces where different people, if they connected to one scene, could send messages to each other. And as for the rest of the semester, I am just wrapping up documentation on how to use these components, and as well as uploading my sketches for future use cases of these components and other affordances in A-Frame. And so as Matthew touched on earlier, so our project is really focused on providing a lot of different external tool sets that artists and musicians can kind of use and build out different things that they want to. So it's really more not about accounting for every possible feature, but just allowing these new abilities with these software. And then the bidirectional OSC bridge allows for a lot of different use cases and workflows. So eventually you will be able to make a digital audio workstation just with our components.
I guess here in a second we're going to try, next time permitting, try a little bit of choreography and actually show you some of this in action. So over kind of in this corner where I've become ensconced with guitar amp and some various hardware knobs and slider controllers. Right now my music software is set up to interface actually with a very simple but hopefully demonstrative virtual environment. So if you like, we're going to throw it up on the screen. But if you want, you can actually go on your own computer to the URL that Drew's putting up now. It'll prompt you for a code, and that will actually bring you into the shared virtual environment that I'll then kind of perform a little for you from. And just like Rachel was saying, we and hopefully all of us might find this useful or inspiring in the sense that it kind of shifts this notion of going to a website. Is the website a place where you see performance? Is the website a kind of media sculpture? What other metaphors can be in shared virtual space? But while there, feel free to join us there.
And so anyone on RPI's campus right now can go ahead and join that room code. Unfortunately, if you are remote, it's not going to work because it only works locally at this point in time. Oh no. Oh no. It's MP610, right? MP610? The code's MP610, right? Yep. Oh no. Oh no. Okay. Really quick bug fixing. Is that an HDMI cable? Is it good if I unplug the HDMI from here, or real quick, or no?
But it's gonna mess up the
Yeah.
WebEx.
Okay, here, I can.
Could we, like, if you joined on the WebEx room on your computer, and then we had screen share with that?
Yeah, you can screen share. You can screen share from that.
Okay, that would work, yeah. If you want to pull me up.
I think what I want to do is pull me down, actually.
Also, just always having stuff I should share on. I come from background in Black music sense. I've always found work with technology. It's not a matter of everything working, but trying to elegantly roll with it when it breaks.
And then the WebEx is not showing it. That's odd.
It's right there. You should be able to just go into the WebEx.
Yeah,
WebEx.
I'm in WebEx right now, yeah.
That looks like Discord. Is it?
No, this is WebEx, yeah. Oh no. Focus. That's unfortunate. Over the mouse.
Huh. Oh, you have to join the room. Did you join the room here?
Yeah. I smell something.
I don't.
Was anyone able to join from their
That is funky. I've never seen that
I don't
before.
know. Well, that's unfortunate, but I don't think we want to waste much more time. I have this. I can walk around them and show people.
Well, here, we can plug that into the screen, and what I'll do is I'll try to take a picture of the screen with a different camera and see if that works. All right.
Yep. Okay, there we go. Sorry about that. Unforeseen bug, but there we go.
Awesome. So look how easy and straight ahead this system is. Awesome. All right. So with all that being said, can make a few bugs being worked out. Anyone should be able to remote whether you're in the same room or not. Obviously, that is not.
I'm seeing is.
So right now, I'm running a max patch and table impact, but you could also use your data, anything that's in OC. Right now, I've got a variety of synthesizers that you notice as I turn these knobs, while in my local situations, I can actually perform these virtual environments. What's exciting about this too is that because this is actually a shared virtual environment, this isn't just a play the sound, get the trippy thing. But actually, Drew, you mind walking around in the environment as I move things with just clicking and dragging your WSD? So you notice this actual thing is an environment you can enter in virtual reality. And we've got affordances for changing the colors of these things, of moving things. In just a moment, this might be loud. I'm going to try something real quick. Again, this has actually been, this whole summer kind of soup to nuts, both conceptualizing and building this. But going back to what we were talking about, building is really exciting. Because beyond just moving these things around, you could actually
All right, do we have any questions? Well, I get myself reconfigured again. All right, wow, and we are.
That's a good question. One of our big future goals actually goes back to our team, but A-Frame is a platform that provides scaffolding for a larger open source tool called Mozilla House. Okay, try now. All right, check. Cool. Sorry, short form is one of the future goals will be adding audience avatars and various audience interactive things. And that's a great
Currently, the two-way communication also does allow for you to send data back from the browsers back to whoever's hosting the world or the room. So that is capable. We just haven't actually implemented it yet. But yeah, it is there.
I'm going to ask one more question. You guys had a lot of different projects out there. How did you choose what other products you were going to kind of incorporate? Like A-Frame and other.
But I don't want to speak for anyone else, but I know when we started this, I'd sort of come in from right when the pandemic came down. I started working a lot with that platform Mozilla Hubs, which is built on A-Frame, which allows a lot of that kind of audience participation. So part of this was kind of looking backwards to sort of see how people have been doing, what have we had success with in the past, and then really kind of presenting that to our team and sort of saying, hey, does this resonate? Does this seem feasible? How could this connect?
Okay, as soon as I get myself back up on the screen.
You look really cool like fractal out.
All right, let's thank Virtual Electronic Music again.
Thank you.
And Elephant ID, are you? I'm sorry, I was muted when we were having some problems. All right, so sorry about that. A little technical difficulties, but we persevered. Elephant ID, am I correct that you guys are set to go?
Yep, we're ready to present. Actually, Professor, do you mind if I share my screen?
Nope, that will work.
Alright, hi everybody. My name is Neha, and I'll be talking about the Systems of Elephant Re-ID project, which we just call Elephant ID for short. So this is an interdisciplinary project, and we have 2 students from Caltech, as well as a team from the Mara Elephant Project in Kenya working on our project. So from the RCOS team, my name is Neha Deshpande, and I'm the project manager. This semester, I mostly worked on the implementing functionality into the webpage, including moving images around.
Hey guys, my name is Astia. I worked on the button that takes you to a matching interface and the arrow button functionality.
Hi, I'm Sneha, and I work on like the hotkeys and the speech comparison.
Hi, I'm Asta, and I worked on the grid view and the gallery view.
So first of all, I'll give some background about what our project is. So I'm sure you all know elephants in Kenya are dying because of poaching and other human-elephant conflicts.
So the best way to try to conserve the elephants is to monitor them. But because there are so many elephants and the national parks in Kenya are so large, this is a pretty difficult problem to tackle. So that's the goal of Elephant Book, which is the project that we're working on. Basically, we work with the rangers in the Mara, which is the region in Kenya, like National Park. Basically, what happens is that the rangers take pictures of the elephants, and then Elephant Book, the website analyzes them to try to identify and monitor the elephants using computer vision. So our goal for this semester during RCOS was to make the interface that the rangers would use matching the unidentified elephant with the images of the elephants that are already in the database. You can see Elephant Book already had a matching interface. You can see that on the slide, the screenshot. But you can see it's kind of slow, clunky, and sort of unintuitive to use. So our UI, which you'll see a bit later on in the slideshow, it's a lot easier to use. It's fast and efficient and understandable. So for our project organization, we use GitHub for our repo. This was quite a large blocker for us because since it's an external project, we had a lot of code that was written to be closed source. But finally, on August 11th, our teammate finally got to making the open source repo. So the license we used, finally we decided on Apache 2.0. The next is the tech stack. We used Django, HTML, CSS, and JavaScript to create the interface. And we also used GitHub's issue tracker. So we use this to track our milestone progress as well as distributing tasks between the 4 team members in RCOS. So this semester, I'd say we made quite a bit of progress. The list of functionality and UI design is taken from our proposal, and you can see we did a lot with the user interface as well as adding quite a bit of functionality. Unfortunately, we weren't able to finish all the functionality, and we definitely need to work on some more testing as well.
So moving on to the UI mockup, we received a UI mockup from our external team, but we did make some changes. So on the left is the mockup that we received, and then on the right is the final mockup with our changes and additional feedback we received from our external team. At first glance, the mockup looks the same. However, there are some key differences. First, we change which side the matching elephants are going to be on. Initially, they were on the left, but because we wanted to plan our design around human intuition, as we read from left to right, we decided to change the matching elephants column to be on the right. Because of this change, we added labels to the column so that it's easier to tell by first glance that the matched elephants are on the right and that the unknown elephant is on the left. Also, this change was beneficial in implementing hotkeys, as the matching elephants have up, down, and left-right arrows, and the unknown elephant only has left-right arrows. Therefore, we changed the hotkeys for the matching elephants to the arrow keys because they are more visually intuitive instead of the WASD keys, which is now for the known elephant hotkeys. Also, we added zoom in and out buttons for the elephant pictures, as we thought that it would be nice for the user to have the option to do so. In addition to these changes, we wanted there to be this individual needs further review option if the algorithm doesn't pull up the correct match. We added a confirm button as well. Overall, the changes that we made to the UI mockup were centered around human intuition and visually appealing features like icons and colored buttons.
Okay, so regarding the user interface, since this would be used by rangers, it needed to be as intuitive as possible. So we have the obvious choice of all the arrow buttons that you see for the mouse, and we also got hotkeys, which, as I explained, basically just to help us move between elephants on the possible matches. So it should also in turn change the seed code and also switch between images so you can figure out your matches better. And also, again, hot A and D for unidentified elephant section is on the left. And yeah, that's left. So yeah, and then we also have some sort of hidden functionality kind of working here. You'll notice that there's a small little scroll, it's like a score button at the bottom of the screen. It's like a gray, black kind of thing. So when you hover over that, it'll like show you a little bit more of like the breakdown of score, like what classes rates it, and it will direct you to the table for, well, more breakdown of C code.
Now we can talk about some of the specific functionality we implemented. On the left, you have a page for the individual sighting of an elephant that is unidentified. On the bottom, there is a match button we made that takes you to our matching interface. On our matching interface, we have a left and right arrow button on both the unidentified elephant and the possible matches. These change the image of the current elephant and also update the image number on the top corner. Next, we have the up and down arrows that are only on the possible match elephants. These cycle through the elephants in the database sorted by the C code score shown in the black box at the bottom. These buttons also change a few things on the page, including the match number at the top, the set of images, the elephant name, C code, and the seek score at the bottom. It also updates the differences in the C code for both the unidentified elephant and possible match elephants. In the top picture, there are 2 differences highlighted in red, and in the second possible match, it shows there are 3.
So for the grid view, this is a feature when the user clicks the grid button and it shows a pop-up that contains all the pictures that the ranger uploads or the matching pictures that are already in the database. The purpose for this button is because usually for one elephant, there will be a large number of images in which going through every picture individually may be too time consuming and just not efficient. So this feature allows for the user to look through all the pictures in a grid view without having to go through the entire image folder individually.
So back to the seek score, which we talked about a little bit earlier. So this is the actual breakdown where you will see that the score is just the curve rank score and the seek score. So the seek score button basically takes you to this specific table. So the rows are basically just all the features of the different elephants. Columns are both represent the elephant and like the differences between them. So that's why you can see like for first elephant that you would see, there's like position 4 and there's none for like saying like if they have a chair in their left ear or if it's like a hole, something like that.
Yeah, so that's it for our project. Does anyone have any questions?
So I guess we're done. So the next person wants to go. I guess that's fine.
My apology, I was talking and I hadn't unmuted my phone because I was trying to, or my microphone because I was trying to resolve all of the echo issues. You'll notice about a third of the way through your presentation, I finally got them knocked out. I just wanted to comment on your struggles for getting this open sourced, and I just wanted to. I'll start setting up the next one while I'm kind of talking or asking questions. But I know you guys had an issue, and I think that it was actually in some ways kind of illustrative of what happens in open source communities, right? You have to build consensus. You have to work out the details because everybody is working voluntarily or working because they choose to work in the community. And so I was happy that you guys finally resolved it. I'm glad that this all worked out. What license did you eventually end up with?
We ended up going with Apache 2.0.
Apache 2.0? That's a good one.
Yep. Yeah.
Okay, any, what, do you want to comment a little bit on the difficulty of building consensus versus the difficulty of doing technical, or are you guys pretty good either way?
Yeah, I can talk about that briefly. So I think the main problem with getting our code to be open source was that it was written by our external team members, and it was like their own code, so they were a bit hesitant at first to make it open source. But in the end, because of choosing the proper license and everything, we were able to convince them, and now it is open source, which is great.
Cool. And that's a big concern for a lot of people a lot of time. This isn't unheard of, and it's not, something that you can just dismiss. Building consensus and getting everybody to agree and finding a solution that pleases everybody keeps things like the great Audacity or MongoDB schisms of the last few years. Poll Buddy, are you ready to go?
We are.
I'm not seeing your slides. Did I just miss them, or you present? Okay, cool.
I would like to present them, but they should be in the chat now.
Okay, I'm happy to have you present them. That is fine with me. It looks like we are already, if you present, I think we are already up, ready for you.
Sounds good. All right, hopefully you should be able to see it now.
Yes.
Excellent. All right, well, assuming we're ready to go, then I will get right into it. So, hello everyone, we are Mobile. I'm Hunter, the project manager, and I'm going to start us off with a brief overview of our app and how we're developing it, and then later you'll hear from some of the other Mobile buddies more in-depth details about different portions of the app. So, jumping right in, what is Mobile? As a quick overview, Mobile is just a website alternative to iPlayers, but better. So iPlayers are classroom tools used to get responses from students, but they do have some major limitations. So what we're doing is we're building a virtual polling system that is affordable, easy to use, and interactive for everyone. We are also now integrated with RCOS past login system and hope to add other integrations like Submit in the future. So we've been working on Mobile for 6 semesters now, it's starting to get pretty long, but we've definitely done lots of designing, building, and refining as we go along, and we're making a lot of good progress. We are hoping to do some beta testing in RCOS at the end of the fall semester now, and take some feedback from that to finish preparations for a wider rollout. We've made a ton of progress over these semesters, and everything has been coming together very nicely. So on this slide, I've linked some of our GitHub organization page, which has all of our repos, and it also contains our licenses, which are the MIT license. As for contributors, everything is open source on GitHub, and you have a wiki with a contribution guide and a bunch of other information about the app, which should aid in development and understanding how everything works together. As for project management, we do track 2 items through GitHub issues, and we link those to monthly milestones to somewhat prioritize them, but we've always been sort of a more laid-back project, so we don't usually stick to this too much, just more of a general guideline. I've also included some assorted stats about the main repo, such as our total number of issues and pull requests over on the right, a language usage breakdown at the top, and our monthly commit numbers at the bottom left. And that's all for me, so now I'll pass it off to Justin to talk about the front end.
We're not hearing you.
I'm agreeing. Do we have a Justin here?
Is there a Justin in the house?
I think so, please. Worst case scenario, I'll cover both. Let's give it a couple seconds to get it works.
Can you guys hear me?
We can now.
Okay, sorry about that.
No worries.
Sorry. Hello, everybody. I am Justin, and I'll be going over the front-end part of this app. So in terms of the technologies that we use for the front end, on the left here, you can see that we use React.js as the framework for FullBuddy. And the thought process behind this decision was primarily because of React's flexibility and how easy it is for new members to pick up this framework. And on the right side, right, you can see that we used React Bootstrap. That gave us a whole bunch of pre-made design components that made developing a bit easier. So in terms of progress this semester, we did complete a variety of tasks, most of which we can see on the slide here. We do still have some things that we need to work on, but we've made a decent amount of progress this semester. So in terms of completed tasks for the front end, much of the login and registration interface was cleaned up and was made more robust. This semester we also added a bit more documentation for the front end, so things like a README for the front end. And lastly, in terms of completed tasks, we also added some functionality for the account management. There are definitely some tasks that we're continuing to work on, such as integrating the back end and front end, as well as early testing. So much of this semester, in terms of my own contributions, I worked on a lot of front-end related issues, and my main goal was to try and improve and hone my skills, especially when it comes to web development and using React. So in terms of documentation, I added a pretty brief but comprehensive README file to kind of outline the whole front-end structure as well as the technologies that we use for it. And especially as the project gets bigger and more complex, this README will hopefully help new members and FullBuddies that enter this project in the future kind of have an easier time to adapt and kind of pick up and start contributing as soon as possible. Other contributions that I made were UI toggles that added a bit more flexibility and functionality. So one toggle that I had would allow users to log out everyone whenever they wanted to reset their password. And the second toggle was for professors and poll creators that wanted to randomize question orders whenever they had 2 or more questions created for poll. And lastly, I worked on touching up some UI elements. So across the site, there were certain UI elements like buttons that were maybe not centered, and I kind of worked to kind of tweak some of these things and fix them. And that's all for me.
Hi everyone, I'm Jacob. This semester I spent most of my time addressing problems on and refining the front end. This was my first time really working with web programming, and it was a really good way to get comfortable using it. A couple of the more visible things I worked on were updating existing components to make them work dynamically with the user's login status and information. For example, I reworked our drop-down menu to display different options to log in users, providing them access to more of the site. I also updated the account page on the user information to load user information and allow them to update these fields. And now for the back end. As a brief overview, we've got several technologies we use in the back end. We use Docker to package up and run the app simply and easily, Node.js to run the JavaScript code we use, Express to make it easy to set up an API, and MongoDB to store all our long-term data. Some of our goals this semester were to further the integration with the front end, to add more documentation functionality, and to renovate some of the early endpoints so they match our current designs and needs. As for our future goals, we aim to finish the front and back end integration, add more functionality on top of our core focus like media integration and anti-cheating, and much, much more. I also spent some time creating the Me backend routes, which provide easy access to the current user's data. Our previous backend routes for users relied on front-end passing the user's ID, and by getting rid of that restriction, these routes can now be used anywhere and aren't reliant on being passed the correct data. They used to use stored at login to access the database and allow us to retrieve the user's name, email, and other information with the Me route. We can edit this information with Me/edit, and we can get all the groups of users part of Me/groups.
Can you hear me?
Yes.
Yep. Okay. My name is is Brian Lynn, and this semester I mostly worked on doing documentation on the back end. This basically included documentation on all the endpoints relating to polls, the poll buddy database, and the technologies we use. There were a couple of sections in the polls specification wiki that didn't have any documentation. So now it has a bunch of information on how to use each endpoint, what they do, what they request, and possible errors that could occur. Each endpoint also has similar information in Java doc style in the code. This formatting style for the wiki documentation of the endpoints have now become a standardized procedure since it was approved by Hunter. Furthermore, this RCOS project utilized JavaScript and React, and we've never used those languages before. So this semester I spent a lot of time learning both JavaScript and React so that I could become familiar with them for possible future opportunities.
Hi, I'm Harry. This semester I mainly focused on backend issues and documentations. I wrote an overview wiki page for backend rules and learned JavaScript in order to solve backend issues. I worked on a validation function that checked user input data is valid compared to the answer in database for co-answer algorithm.
Hi, I'm Jeremy Gong. This semester, I learned JavaScript and mainly worked on backend documentation. I documented the route flows in code and wiki used the main parameters and return values in different conditions. For any related information, I also added a reference in the documentation for people to check them easily.
Alright, so this has been Polybuddy. Does anyone have any questions?
You guys are way too quiet today. No one has any questions for Polybuddy. All right, so the one I have is you guys have been working on, so you have all the login stuff and you're making it work with the RPI login. Are you using CAS?
Yep.
So did the changes to CAS impact you guys, or did it just continue to work as long as your VPN'd in?
We didn't even have to use the VPN. It kept working just fine. No changes were required. I think what RPI did is they rolled out like several versions of CAS, so
Okay.
depending on how you access it. So I think we're just using an old version still that just keeps working. So
Gotcha.
we might have to update that to the new one at some point, but for now it's been fine.
So one of the things that I was wondering about is, when you use something like CAS, are you closing the doors? Are you making it harder for other people to pick up your project, or is there a way to kind of easily swap out components that are specific to RPI?
That is actually something that we have made a decent effort to make as open as possible. So we do have a built-in login system, just like our app. Login rather than using RPIs. You can use either, it links to the same account basically. But we do also have that whole RPI system segmented away, so you can pretty easily just copy and paste the RPI login file and just tweak it to your school's or organization's login system pretty easily. And we also have like a drop-down list, so they can even say fork the project and fork us back in their login system and implement it on the main site.
Cool. I think that's an important thing to keep in mind, and it sounds like you're actually thinking about it, so that's a good thing. Okay, can you relinquish the screen? I think we're going to go to our penultimate one for today. Elira, am I pronouncing that correctly? Yeah. All right. It looks like I'm getting good at this. It looks like we're up. All right, I am going to go to the back. Or sit down.
All right, so I'm Antonio, and I'll be going through Elira. So I'm the only RCOS member on this project this semester, and our IBM lead is Carlos Spoldaro. And I have to do a lot of backtracking in order to explain what's going on with Elira. So I'll get through this first. So first, I have to explain what a Jupyter Notebook is. If you don't know, essentially you have a file that's pretty much running a script, whether it's a Python script, R, doesn't matter. It's running the script, and what's special about it is you're able to format the data that's being analyzed by this notebook during the script in pretty much however format you want. And what makes it so useful is mostly for data science. So you can imagine I have a script that does one thing constantly the same way, except what could vary is the data you put into it. So you may want to run the script multiple times with different data sets, and you'll get varying data, and you'll be able to get live results and see those results. Now this is relevant to Jupyter Lab. Jupyter Lab is the environment which you can work with these notebooks, and it's open source and it's extensible and very flexible. And this is where Elira actually comes in. So Elira is an extension or a set of extensions for Jupyter Lab. And the idea is that the main point is the AI pipelines, the visual editor for those pipelines. And all these other things, it may look a little daunting, but this is actually, I found this daunting at first, but a lot of it's sort of redundant in a sense, at least conceptually. So you have the pipelines. I'll explain that later, don't worry. You can run your notebooks, your Python scripts, your R scripts, all that is a batch job. Same way as a single node in the visual editor. You have your reusable code snippets. You're able to use that to grab code from different languages and easily make your workflow a little faster. And the next two bullets are actually related to outsourcing your pipelines so that you don't actually have to run them locally on your machine. So that's the idea. You can run them locally, but say you have something huge, you need to run something, you need multiple cores to run whatever data analysis you're doing because you have so much data, you can outsource that. Right now, there's implementation for kubeflow pipelines and airflow pipelines. And from there, we have table of contents for both Python scripts and notebooks. Make it easier to jump through on both of those and navigate through them. Then we have the language server protocol integration, which is just a fancy way of saying language-specific integration, like something like Kite, for example. It helps basically make the editor feel like it's actually helping you. And then you have version control using Git. And if you've ever used an IDE that had Git, same simple idea. You commit, pull, what have you, and you can also look at your difference changes, the highlights in red and green, just like you would on GitHub. All right, so this is straight from the docs. This is the selling point of Elira. It's about the pipelines. So the idea is that if you're a data scientist, you're actually trying to work on this AI pipeline for a model. It's annoying. It's hard. You gotta, you run whatever model you have, and it could be quite tedious to keep doing this whole project, over and over again. Now you can make this easier by running it through what I already described is the notebook, Jupyter Notebook. The problem with that is, say I want to run this whole process, right, to make this whole process seamless. But much like if you could imagine a function that just did everything you wanted in one go, but ended up reusing components, you'd want to modularize all these things. You want to make more functions that did those things separately. So this is the idea of the pipelines. So this is what you'll see if you open up Jupyter Lab with Elira as your extension. Right here, you're looking at some files that they have, the example docs. The idea is you build your own pipeline here. They give you some files. Normally, you'd have to make this your own. And you just drag them right in. You have a generic pipeline editor right here. You drag them right in, and that's it, straightforward. You drag them in. Certain things like, for example, in this case, they want a URL for the data set. You just type that back in. And if you want to export this, you can to Kubeflow, Apache Airflow. And yeah, pretty straightforward from there. This is the data that you'll get when you run it. You'll see that there's a whole new folder for the data, as well as you'll see the updates on some of the things you threw in there because they're notebooks and they update live. So project organization, pretty basic. We're just working through GitHub. You got, if you want help, you go through Gitter if it's not something you want to ask on a pull request or an issue. And they're very helpful. And there's also weekly meetings, and they're very community oriented and very welcoming. So yeah. As far as what I did, my main accomplishment was the describe command, and all the other stuff was pretty much small like documentation changes. But yeah, I'll get to the describe command. So describe, the idea is that from the command line, you want to be able to read this file. This file was not meant to be read by humans, clearly. And you may notice, you may recognize this as a JSON file, which is pretty much just a Python dictionary. And yeah, this file, I want to remind you of that example pipeline I showed up there that had 4 nodes on it. This is the same file. So this is the back end of it, and this is what it looks like. And the front end makes it look all pretty, but really it's 315 lines. So this is the idea, is that you put in the path to that file with the describe command before it, and this is what you get. Pretty straightforward. And this is if you add the flag for the JSON file, you get the output as a JSON. So yeah, what I needed for that is the backend's Python, front end JavaScript. So I was back end doing Python, used the click module for the CLI, and JSON module for input-output, and Flake was just meant to annoy me with formatting. That was pretty much it. And yeah, as far as my work in progress, I just gotta add implementation for, well, it's already added. I just need to pull it from a colleague's branch, and that's pretty much it. Other than that, I've got an issue with how these things update due to make, and yeah, that's pretty much it. I purposely skipped a lot, so I expect questions, but.
Anybody on a lighter?
Yeah.
Just really general, just out of curiosity. Just wondering if, like, what kind of use case of data analysis or AI research?
Yeah. So for example, that one pipeline I showed you, I could go through that example, but that's like really simple. Say I take there was JupyterCon from 2020. They showed their example was related to COVID, and you could actually see based on the data, the COVID data that they inputted, you get different graphs showing, okay, well, this is the rate, and this is what you expect, predictions, what have you. And as the data updates, you'll actually get the pipeline to update. And so that way you don't have to constantly run this all over and over again. This will just happen every time you open it back up in JupyterLab. You just see it right there. So yeah, the idea is that it makes this whole process seamless. And say I wanted to, and this is another point they made, say I wanted to clean up that data, right? So my pipeline would be useless if I needed to now just break off this whole part and add this new thing that, maybe I want to keep the rest. It might be annoying to just go and say, oh, I need to also add this part that cleans the data, and maybe I want to remove that. You could just make a whole notebook just for cleaning data and just put that right in there, and it'll clean the data for you.
Cool. So I guess one question that I'm going to ask while we're getting set up for the next person or next group. Actually, I didn't check. Are there any questions any questions online? Hunter and Nia, can you be intermediate if there are any? If not, so one of the things that I was interested in is the goal of this project to create an environment for creating pipelines, or is it to create pipelines?
Oh, it's the environment.
The environment. So you're putting together all the pieces so that all those components, like if I wanted to add some pipeline stages, I could do that. Like
yeah,
okay.
Yeah, easily. That's the goal, to make this a seamless process. The idea is it's marketed mostly towards like the data scientists. So yeah, that's pretty
Cool. All right, and that was an IBM project, by the way. I don't know if I've hit all the projects. Tutor has Professor Uzma. Let's see, who else did we have today so far? Open circuits, Leon is actually a master's student now, I think. Elephant ID, Professor Stewart, and some collaborators at Caltech, I believe. Virtual electronic music, we have one of our arts department people doing some really great work. Poll Buddy, you guys are all RCOS, but you've been here a long time. And then Elira and Walla CodeNet are both IBM. And Walla CodeNet is next and are hopefully walking their way up as I'm speaking, but I'm not seeing them moving. So this is the last one for today, which is good. We're a little bit behind schedule, but we're not so far behind schedule that we'll have to go past our 3:35 stop. Isn't summer's wonderful? We have a whole 2 hours and 5 minutes, so we can actually get through these. I'm gonna let you guys come up. You all set to? Yep.
One of our group members is online, just making sure that he's there.
Are you there?
Yeah, I'm here.
Okay, perfect.
Okay,
Just
and we're
making
hearing
sure.
you good.
Thank you.
All right, so we are the group working on IBM Walla CodeNet. And so the contributors to this project are me, Vin,
I'm Andy.
Tenzin.
and the one online is Ian.
Yeah, hi. Thanks, man.
No problem. So what is Walla? So Walla is short for the TJ Watson Libraries for Analysis, which essentially is an IBM project that is meant to analyze Java, JavaScript, and Python programs and try and figure out what the program does or what the code does. And so in particular, the project uses classification or traditional analysis features such as call graphs and system dependence graphs. And that's Walla. And so now I'm going to move on to Project CodeNet.
CodeNet you consider to be sort of like use cases for Walla. Walla serves as the backend, and CodeNet is the examples you use it on. And what CodeNet is itself is this set of code, like answers for coding problems that IBM collected. So they had a series of questions they would ask to which people would submit answers. And I believe there were 14 million accepted examples. I think there were about 2 million that they didn't accept because they either weren't correct or it didn't end up being like useful. And the idea behind CodeNet is now you have this really large data set of solutions and problems. And that's where Walla comes in, because now we can run the analysis that Walla does on all of these code, on all of these like pieces of code, and then get like what they were anticipated to have done. It's pretty much like a labeled data set of code.
So just some background on the Walla repo. Walla runs an Eclipse public license, which has been verified by the OSI. At the current time, there's no formal issue tracking. Issues are assigned to contributors. So that led to our work, which was basically contributing substantial documentation for helping out new developers. And the CodeNet repo setup, CodeNet instead runs the Apache license. And similar to Walla, there is no formal issue tracking, and issues are instead assigned to contributors as the issuer sees fit.
Okay, and then so for our goals, when we were talking to our external lead, Julian from IBM, our proposed goals were to possibly redesign call graph implementation and improve Python and JavaScript analyses. More specifically, when they were running tests, Java analyses had about a 94% accuracy rate, which is pretty good. As for Python, it had more of like an 89% or 88% accuracy rate, which Julian wanted us to potentially look at and improve. He proposed that system dependence graphs maybe weren't the best representation for the, I guess, lack of complexity of the Python language compared to something like Java. As we were actually working on the project throughout this whole semester, our new realized goals and things that we achieved were more towards documentation. So we developed cross-platform compatibility. We also, towards the end of the semester, worked on null pointer analysis script for Java, so we looked through that file and worked on that. And like I said before, we got large amounts of documentation, and then that we will go into as we look into each of our contributions. As for next steps, so Julian has agreed to work with us next semester. Some of us will be away, some of us will be working on it. We will look at more of the analyses. So like I said before, we were looking at null pointer for the last couple weeks. However, there's obviously a lot more analyses that we can look into. We also will do the updated GitHub repo, and we also are looking into compiler integration with the Magpie Bridge program that Julian actually made himself.
So one thing to note about the project is that it is new to RCOS, so we're all running into issues getting set up, getting running. And a little bit further on that, every single one of us in the group had a different system installed. So I was running a pure Linux, for which it was designed. The only issue with that is the code base that was being run is different than the one that we ended up setting up Docker for. So I had to pretty much patch all of the package and download compatibilities. Likewise, I had to deal with a couple of JDK issues, notably one which required almost porting it to JDK 11. And then the documentation for how to do that on a pure Linux install. And yeah, otherwise it was most documentation getting it to install Linux, and then also like some layer bits on JDK agreement.
So like what Ian said, Wall was not meant to be run on Windows, it was meant to be run on Linux. So so Julian came up with the idea to use Docker so we could run on our machines. So my setup was since I had a GPU which was needed for the Walla analysis, I wrote documentation on how to set up Docker running through WSL2 instead of through the native Windows. Also documented the process for allowing GPU support through Docker, which includes like downloading drivers, downloading like Windows Insider versions and all that. And I also documented how to set up the development environment in the container using IntelliJ specifically.
Yeah, so as stated before by the previous two, Project CodeNet was missing a lot of documentation just in general. So I also helped contribute to that by documenting the onboarding process for a Docker environment on Windows, as well as installing Eclipse onto the Docker image. And I also, later on in the semester, I ran and analyzed several null pointer analysis tests on the Docker container of Project CodeNet. And since the project is so large and complex, sometimes the packages that are needed for testing aren't there, so I had to change and import various packages and libraries or redirect them to different directories in order to develop proper testing material. And then later on, I also wrote additional testing code for the for one of the analysis objects, the null pointer analysis.
All right, and then for me, I was using Windows PowerShell, and I used Docker with that. And then I know a lot of my past teammates were talking about like the development environment, and that was on VNC Viewer. So we'd run the Docker image, and then we get that on VNC Viewer so that we can actually get like the terminal on the viewer to run all of our analyses. And past that, we wrote documentation on how to commit an image with all the work that you've been doing on the development environment. For me, I used IntelliJ, so I downloaded that into my development environment, wrote documentation on that. Lastly, in the next steps, I was talking about compiler integration for next semester. So Julian wrote a longer research paper about Magpie Bridge and how, or what it's actually about. So I wrote a little report on that and how we will slowly integrate that into what we are doing currently. And with that being said, I want to extend our thanks to Julian and for Professor Turner for helping us out with Docker in the beginning and for getting us access to the Amos supercomputer. Super excited for that.
Thank you. All right, do we have any questions from online? Any questions in the room? You know I'm not gonna let you go. I had a question.
So the WALA, what it actually is just the analyses. Magpie Bridge is, I guess, like getting that into an IDE. So that's like where you're actually doing the analysis. So if, for example, when we were talking to Professor Turner during like one of the mid-report type things, he said that it would be super useful for something like a CS, 100 class where you need some type of analyses to run, like how effective your code is, something like that.
Okay. There's all sorts of technical questions I want to ask you, but I'm going to focus this time on an open source question.
Okay.
WALA's under Eclipse and CodeNet's under Apache.
Mm-hmm.
Are they compatible, and why one and why would you pick one over the other? Have you looked at that at all?
Yeah, so Project CodeNet is for running WALA analyses tests on various, I guess for lack of a better word, tests. And so I don't think, or we haven't used WALA, or haven't directly used or contributed directly to WALA yet. We've only been contributing to Project CodeNet. I'd imagine they should be compatible, but I'm not too sure.
Might be something to look at, just to make sure, because there are sometimes intricacies. I don't, nothing, depending on how you're doing it, doesn't seem to me to be anything too bad, but I seem to remember that Apache is more permissive than Eclipse, I think. Although I would have to check. Maybe I could just be confusing. There's like 10,000 of them.
Yeah.
Right? So, but just, just check it out.
Yeah, of course.
Good. Any other questions? All right, so I think that wraps up today. We have another one tomorrow. Again, if you're here or can run down here in the next 30 seconds, I have RCOS t-shirts. You are welcome to grab one. You're encouraged to grab one. Let's raise our profile on campus. Other than that, let's give one more round of applause for all of our presentations today. And then let's give another round of applause for all of the mentors we have. Like I said, we had a lot of them on these projects. This was kind of a mentor-heavy day. So let's give them a round of applause, too. And thanks to our RVM guys, people again. All right. Long day, good presentations.